Hi everyone, let's start on example 10. So again, we're starting from the angle that is not the right angle, which is x. Remember, in all of these we're solving for x. Okay, and I'm going to label the sides of my right triangle so I know which trig function to use. Okay, so the 13 is the side directly across from my angle. Okay, so the 13, the side across from it, is going to be which side of my right triangle? That would be the opposite side. And the 6 is the side right next to my angle that is not the hypotenuse, because don't forget the hypotenuse is the side directly across from the right angle. So what is this side called? Yes, you guys are brilliant. That would be the adjacent side. Okay, so which trig function has an opposite and an adjacent in it? Man, you guys are too cool for school. You always know the right answer. It would be tangent. Okay, so tangent is the opposite over the adjacent. Okay, so we're going to be using tangent to solve this problem. So I'm going to set it up just like how we normally would. So tangent of my angle, I don't know the angle, so I'm just going to write x degrees equals the opposite over the adjacent. So my opposite side is 13 and my adjacent side is 6. And again, you can try to reduce that down. I can't reduce down 13 over 6. And again, since we're typing everything in the calculator, in this case it doesn't really matter if you reduce it down, but it doesn't always hurt to practice. Okay, so currently my x is trapped inside of the tangent. Okay, I need to get rid of this tangent so I can solve for x. Okay, so in order to cancel out the tangent, we need to perform the inverse to tangent, which is inverse tangent. Look at that. Okay, so I'm going to take the inverse tangent of both sides to get rid of that tangent and get x by itself. Okay, so I'm going to take the inverse tangent, which remember, the way we write inverse is to raise it to the -1. Okay, we're not actually raising anything in the -1. It's just our fancy notation for inverse tangent. So instead of writing inverse tangent, I'm going to write tan to the -1. Okay? All right, and I'm going to take the inverse tangent of both sides. Okay, so this will be tangent of x degrees. And this will be 13 over 6. So I've taken the inverse tangent of both sides because the inverse will always cancel out the other function that its inverse is 2. Okay? So anyway, since tangent, inverse tangent are inverses, they will cancel each other out. And look at that. I'm left with the x. So x degrees will equal the inverse tangent of 13 over 6. Alright, so from here you just type this bad boy in your calculator. So remember, the way that you get to the inverse trig function buttons, you have to hit second and then you hit the trig function. So second tan will make it appear as inverse tangent. And then I just type 13 divided by 6. I'm going to close that parenthesis. And that will equal, let's round to the nearest degree, so that 0.2 will not bump up to 65. So x will simply be 65 degrees. Alright, and if you like Desmos, I'll show you how to type it in on there. So on Desmos, sorry, let me get out of this. I'm just going to type it in because in my opinion that's the easiest. So I'm going to type tangent. I'm going to hit shift 6 to get it to the exponent. I'm going to type -1. I'm going to hit the right arrow key over and then parenthesis 13 slash or divided by 6. And look at that. If you want to close the parenthesis, you have to arrow over twice and then hit the parenthesis. But if you see, you don't even really need to hit it. So there you go. We got 65 degrees. And don't forget, you can also get the inverse tangent button by going to functions. Make sure you're in the trig part and then hit inverse tangent. So there you go. That's it, you guys.